Hi, welcome to this tutorial that will show you how to create a Bejewelled type game in Unity for Android or for iOS. It'll also work on the PC or Mac as well. So I'll just run what I've got here to show you what it's going to look like. We have a number of different smiley face tiles in this grid system, and you can match 3 in order to get the tiles to disappear and to create new tiles. So if I find another match, here's 3 here, swap those over, and you can see that the grid automatically renews and the tiles shuffle down. So this is what we're aiming for. All right, so let's get started. So the first thing we're going to do is create a new project, and we're going to create a 2D project. So when you open up the new project dialog, make sure that you've selected the 2D as shown here, and we're going to call it Bejewelled. And create that. I don't want to save the previous project I was working on. Okay, now once this opens, what we want to do is to put it into Android mode and set our camera to be looking at a portrait scene. All right, here we go. So let's go to build settings, set it to Android. You want to do this as early as possible in your project, otherwise it needs to rebuild all of the assets. So if you have a really large project and you haven't switched it over to Android or iOS, it will then spend a long time changing all of your assets over to be suitable for mobile platforms. So we've set it to there. We're going to switch platform to Android, which should be quite quick because there's nothing in there. Right, so we just shut that down. You'll now see that you've got Android up the top here, and we'll set it in the game view to be in a portrait mode, which it already is here. In the scene, which is set to 2D automatically because you set it as a 2D project, you will see the interface, or what is basically the camera boundary, by this line here. Okay, so the first thing we need to do is to create some sprites. The sprite will act as a tile in the game. So under Game Project, 2D Object, select Sprite. Now you won't be able to see this sprite in the scene until you've added a texture to it. So what we're going to do is bring in a texture atlas, which I've prepared earlier. So I'll drag this one in here. It's called smileyatlas.png, and you can see if we preview it down here, we've got 6 different emoticon faces that we'll use for the face of each of the tiles. Now we want to split this up into single sprites so that we can put one face on each tile. So with that selected, that atlas, in the inspector you want to select multiple from the sprite mode, and then select sprite editor, apply those settings, and here you can see all of these. What we're going to do is now slice this up. So we select slice. Now if we slice automatically, you can see these slices here, which does pick up each of the faces, but not very nicely, and you can see it's only picked up this whole one here. I think there's probably a few colored pixels between these faces at the top, which means it can't find a nice clear border. So we will just do it by grid size, and these grids are about 96. So if we go 96 by 96 and then hit slice, it will give us a clear delineation around all of these different sprites. Now what I've found is that a sprite that is 96 by 96 is the perfect size for a tile that is sized 1 by 1 in our game world, and you'll see why this is important in a moment. So let's just apply that and close it. Okay, now we've got our sprite over here. Let's just, while we've got hold of it, call it tile, because that's what it's going to be. And in the inspector, we're going to set its sprite to one of these sprites that we've just cut out of the atlas. Let's go to the first one. We drag that over, drop it in, and we can see our smiley face sprite. Okay, now this sprite, if you have a look at its properties, you'll see that it is at 0, 0, 0, which is where we want it, and it is of size 1, 1, 1. Now what we're going to do is procedurally create our grid of tiles. So we need to know that they're all exactly the same size. If they're of size 1, then they're really, really easy to work with. So let me just show you an example. This sprite, which is at position 0, 0, 0 of size 1, 1, 1, if we create a copy of it, so if I just go Control Duplicate to create another one, and then if we just move it around, you can see we've got 2. If I put this sprite at position 1, 1 in the Y, then we get a nice alignment of these two here. So since these are round icons, you probably can't see how nicely those tiles actually sit together, but once we start to create a whole board of these tiles, you'll see that they fit. And just to demonstrate, I'll just create another one. So Control D for a duplicate, and let's put this one just at 0, 1, and you can see that it fits in nicely there. And then if we were to create another duplicate and put that at 1, 0, we now have our mini little grid. So we know that each tile is offset from its neighbour by exactly 1 in either the X or the Y, which is going to come in handy when we start to generate this game board with code. Now, just while we've got these little guys here, what we also need to do is move the camera so that this first one is down in the bottom corner, so that when we build our grid, it fits inside the camera. So if you just grab hold of the camera, and we can then move it, use the W key to select the camera's axes, and then just move it to about there. Now, if these don't fit later, we can adjust the camera. Just as a note also, your camera in this case is going to be orthographic with a size of 5. That's the default camera you get with a 2D project. Okay, so now we've got this. Let's get rid of our duplicates because we no longer need those. And we're left with our single tile. This single tile is going to become our prefab, or an initial prefab anyway. So let's grab that tile and drag it down into the project assets area, which will create our tile prefab. Now we'll just leave this guy here for a moment, come back and delete him later. So we're going to create the code that will build our grid for us. To do that, create in the project a new C# script and call it create game. I've got one I programmed previously, so I'll just drag that in, but for you, just go create C# and rename it to create game. So here's the create game script, and I'll show you what's inside. All right, so we've got, first of all, this tile class. Now you may want to pause the video as you type this out. I'll just see if I can get this a bit bigger for you. Try and zoom it in a bit. There we go. So that you can actually see the code more clearly. Let's bring this out. Does that fit in? Yep. Okay, great. So I'll probably go a bit bigger with that as well. Right, so at the beginning of our Create Game code, we've got some libraries that we're bringing in, the Unity Engine one and the system.collections. Now, this will come in automatically when you create your C# file. Next, we've got two classes. You may not have used two classes inside of a script before, but this one has created a really simple class for each tile. So each tile in the game eventually will have a different face on it. And the idea is to match the faces so that we can get 3 disappear that are in a row. So therefore each tile needs to know what type of tile it is, what face is on that tile. And so we're going to use a string here. Oh, that's terrible highlighting. Here to keep a track of what face is on that tile. And then we've also got a pointer, a game object, to the actual tile that's on the screen. So this class will keep track of each tile for us. So we put that above the monobehavior class, the automatic one that is created in Unity. Right, so let's just now go down to this part of our code. We're going to start selecting a tile and then releasing it in order to swap it with another tile. When we touch it on the screen, we're going to need to keep track of those 2 tiles. So I've created these 2 pointers here. We'll use those later. Don't worry about them for now, but you can type them in. Okay, we then have, just going down a bit further, static int for rows and the column. So this is how many rows and this is how many columns this code is going to create of our tiles. The next important thing is this line of code here, which is a 2-dimensional array which will keep track of all the tiles. So once the tiles are created on the screen, we're actually going to put them inside this array so that we can find each one programmatically. So that the first tile, the one down in the bottom corner, is going to be tile 0, 0. The one above that would be tile 0, 1 because it would be in the 0th position. Remember, arrays start counting from 0, and then it would be in the first row, which is that first one up there. So this is a very important array. Now, the next part of the code that you need to include is this start function. This start function is what generates the grid. So we're going to loop through row by row, column by column, create a tile, and we're going to put it on the screen at the column row position. So we're going to use the column number as our X position and the row number as our Y position. That's why we wanted to have each tile at a distance of exactly 1 from each other. So that the tile's name, the tile's position in this array, and its XY position on the screen all line up. And once we've created our tile and we've put it at that position on the screen with this code here, we're then going to add that tile into that array. And we're going to use the tile itself and the tile's name. We'll come back to name in a moment. This is not important, but we'll, for now, but we'll need to give each tile its own name so that we can check whether it's like the same type as another one. Right, so that's all you need to start with. Don't worry about this update function for now. You can just leave that out. All we need really is this tile class at the top, and then our create game with the start function, all of this, okay, to the start function, and just leave the update empty. Okay, so save that, and I'll just close it and put it out of the way for now. Okay, so here's our create game code. What we're going to do is attach it to the main camera, And then if we select the main camera and have a look over in our inspector, we've got a public exposed variable wanting our tile. Now this is the prefab we created before. So here's our tile prefab, and we're going to drag that onto this code. So now it'll use that prefab to generate all of those tiles that are in the grid. Okay, so now if we run that, we can have a look at what we get. Now we've only got one prefab with one face on it, so we're going to get the same face over and over again. And you can see that the way I've got the camera aligned here, you can probably fit another column and possibly another row, maybe even 2 rows up there. So it might be worth playing around with. Because of the way this is generated programmatically, you can create an enormous array. So let's just go back into our code. And if we add another row, we can just do up here with 9, and we can make another column, set that to 6, and save that, and just switch back to Unity and run it. And there, so now we've got 9 by 6, which fits nicely into that particular size. Right, so now we're going to create all of those 6 different tiles. I must apologise for the crows in the background. If you can't tell from my accent, I'm in Australia. And I think there's like a Stephen King movie going on or something outside. So just try and ignore that. So let's duplicate this tile, and we're going to create 6 of them, one for each of those faces we had. But before we do that, to make less work for ourselves later, is we need to add a collider onto this little guy so that when we click on or touch it, it will register that. Okay, so we go add component, we want physics 2D, and then we want to find something that's going to fit around that. So we'll go with a box collider because it is a tile. And then we should see, if we select our tile up here in the hierarchy, that it's now got a little green box around it showing us this, that it's got the 2D collider. Right, so this prefab here, let's not get mixed up with the guy that's on the screen, even though he's a copy of the prefab. And in fact, let's just get rid of that right now so we don't get confused. Okay, so this tile here is Smiley. So to rename that, and then Control D to duplicate. Okay, and then we're going to add a different texture on it. So we've already got this 0, 1, so we'll put the number 1 onto here, swap it, which will make that here. So, I don't know what that is. Sad face. So let's just give it a name. It doesn't really look sad though, does he? Thoughtful. Anyway, we'll call him sad. And then we duplicate it, and we do this same thing over and over again, adding different images. You might need to click back to it. Okay, now we have a goofy face. I don't know. These are unusual to name. I'll just call it Goofy. And just continue until we get all of our sprites onto different ones. I'll just call that Think. Duplicate it. And probably are wondering what I'm going to call this one. No idea. Let's just call it Tongue, I suppose. And 1, 2, 3, 4, 5, the last one. Duplicate that. And put this one on there. Oh, that's definitely angry. So let's put angry onto this fella. Okay, let's call that angry. Right, so we now have 1, 2, 3, 4, 5, 6 tiles with different faces on them. Right, now what we want to do is to update our create game script to add in multiple tiles instead of just the one here. So in our project, we've now got 6 different prefabs for each of our tiles, and we're going to bring them into our script. Now we could make them individual game objects, but we're going to put them into an array as it will be easier to loop through and process and create them and that kind of thing. So let's switch back to our create game script, and what we need to do is inside the create game class is to change the exposed variable of tile into an array. And we do that by putting 2 square brackets at the end like that. Now, if you save it at this point, you'll get an error because further down here where we're creating tiles, this is all changed because we're dealing with an array. We're not dealing with a single tile. So we could pick one of these tiles and use those instead. But just for now, what I want you to do is to remove those 2 lines because we're going to rewrite them. So let's take them out. And this will now just loop around and create vectors, which won't affect what I'm trying to show you at the moment. Okay, so the important thing is this game object and to remove the guts of this nested for loop. So save that and switch back to Unity. Select your main camera. Then over in the inspector, you'll find that tile has now become an array and you can set the size. So if we make that 6 and hit enter, you'll now have 6 elements where you can drag your prefabs. So let's put in these prefabs for each of the tiles. Doesn't matter what order they're in. We want our game to be random anyway, and we'll do some more randomness a little bit later. First of all, let's just put these guys into here. Okay, if we run it now, it's not going to do anything because we took all the code out that actually creates all the tiles. And that was good because before we were instantiating, using instantiate to pull all of these tiles into existence. Now, with a mobile game, that's a really bad idea. In fact, it's probably a bad idea with any game to be instantiating objects and destroying them all the time inside the update loop because it takes up a lot of computer processing to keep doing that. And even when you do destroy something with the code, it's still sitting in memory for a long time until it gets sort of cleaned up by the internal processes. So the next step is to actually create a bank of tiles that happens right at the beginning, instantiate a whole heap of them, and then to use that pool of game objects to bring them into our grid as we need them. So that the whole lot is created and existing in memory right from the beginning, and we don't need to go through the process of having to instantiate all the time. Right, so to do that requires a fair bit of extra coding into our create game, so we better get started. So open up the create game script again, and we're now going to create our list of game objects, or our pool of game objects. We're going to use a construct called a list, which is a glorified array and has all these cool functions and methods that you can use with it, which will make it a little easier to implement. So the code we're going to type in is in the create game class, and it goes in underneath game object. And this will be list with a capital L, and then game object inside pointy brackets, and we'll call this tile bank, which will equal a new list of game object and rounded brackets. So that will create it for us. Now, if we save this, it's going to give us an error because it doesn't know what list is. We need to add at the top of our program using system.collections.generic, like that. All right. Now we've got this list created, we can now populate it. So to put objects into the list, we have to do it programmatically. So before we initialize our list, we're going to have to add some code in here. So just inside the start, we're going to add this code to generate all of our tiles and fill up that list. So I'm going to go int num copies equals rows times cols divided by 3. So we've got enough copies of each tile to keep the game going, that we don't run out. 4 int I equals 0. I is less than num copies. Oops, num copies. I plus plus. And then we have another nested loop for int j equals 0. This loop will loop around the tiles in the array, the ones that we have passed to this class, like the smiley prefab and the angry prefab and those things. And if that length of array changes, this code will just take care of it. So you can actually add as many different face tiles as you like and not have to modify this code. Okay, so we're going to loop through each one. Then we go game object. Let's call it O equals game object. This is where the instantiation will happen, and we're happening in the start, so it's all right. So this is where we will pull all of these things out. Instantiation. Shouldn't try and talk and type at the same time. It's not my strong point. Tile J, and then I'll just go down to a new line so I don't run out of space here. New vector 3. And we're going to set these newly created tiles elsewhere so they don't show up on the screen. So we set them at -10, 10, 0. So you can imagine that there is a stack of these tiles sitting off of the side of the screen, out of the view of the camera. Tile J dot transform dot rotation. So we're going to keep the original rotation of the prefab, which should just be 0, 0, 0, because you wouldn't have done anything else with it. And then we will do a set active to false and tile bank dot add 0, not 0, sorry, O, the tile name. So the tile name is O. We're going to create it by instantiating one of the prefabs. We're then going to set it to be false, active with an I. And we're then going to add it to the tile bank, which is our list, and add O, we'll add it into there. Okay, so now if we save this, and let's just switch back to here and ensure we haven't got any errors at this point. Okay, so that's good. Okay, we can't run this yet. It's still not going to really do anything. It will create our tile bank, obviously, but you won't be able to see it because you're not using it for anything. All right, so the next part is, once you've created this tile bank, is that we can actually shuffle it. Because this is going through each tile one by one, this loop here, okay, going through each of the tiles in that array and putting them one by one into what's it called? The list, into this list up here. And that means they're always going to be in the same order every time that we run this program, which isn't going to be very interesting. So we're going to create a function to shuffle the tiles. So let's do that down here above start. We're going to add in another function, and we're going to call it shuffle. I'm going to cheat by copying my code that I've already got. So this is the shuffle list function, and what it's going to do is randomly pull tiles out of our tile array and pull them randomly out of this list and swap them around. And it does that a few times. So it picks up one random tile and then swaps it with another random tile and puts it back into the list so that they're all in random order. Okay, and then we want to use that function down in here in the start after we've created that list. So just down after that for loop, we're going to put shuffle list brackets. Okay, so this is the shuffle list. You might want to pause it while you're typing that in, and then we actually call it down here. Now the next stage is to pull the tiles out of that random list and use them to create our grid. So this is where we come back to our nested for loop of rows and columns that before they instantiated the tiles, now we're just going to grab them from that tile bank. So this next bit of code is going to loop through the entire tile bank and pull out all of the tiles, or as many as it needs, I should say, and fill up your grid. So inside these nested fors for row and columns, after the tile pos, which still needs to set our tiles at the 1, 0, 1, 1, all those sorts of positions, we're going to put in this bit of code here. Okay, so we're going to loop through the tile bank for the number of tiles that are in there. We're then going to grab each one in turn. If it's not active, we will then use it. If it's already active, then it's in the grid. So this is one way of telling whether that tile's being used or not. And you can see it tests for it not being active. It uses it, okay, it moves it into position. So remember, it already exists off the screen at -10, -10. So we're going to activate it and move it into position, and then we're going to set it to be active so that it's visible. We then set the tile itself when we put it back into our multi-dimensional array. So remember, really early on we created this two-dimensional array indexed by column and row, and now we're putting our tiles back into it. And then what we're going to do is update our tile count, and then we start the process again by going around. Okay, so once you've got all of that added in, then we need to save our script and just switch back to Unity and run it. And we now have a nice 2x2 grid made of random emoticon faces, just like that. And they're all pulled out of that bank. Okay, so let's stop playing and we'll go back to our script. This code needs to be in the update function. So far you should have nothing in your update function. What we're going to do is register when the mouse is down. So input.get mouse button down 0, which is the first mouse button. This will also register a touch on the screen on your mobile device. So The nice thing about this is that we can test it in the editor and have it work on a mobile device without having to use the input touch values and functions. So the first part is to register if there's been a touch or a mouse button down. If there has, we then shoot a ray from the mouse's position into the screen, and we test if it hits anything with a physics 2D raycast intersection. Our objects have our 2D box collider on it, if you remember from earlier on. So we therefore need to implement these 2D constructs, not the 3D ones. Otherwise, it won't register a hit. So we do a raycast into the scene then we determine whether it's actually hit anything. So if hit is something on the first press, then we're going to set our tile variable. Remember, we created 2 game objects that we set to null right at the start. And if we go right up to the top, you can see that they're still sitting there. These are the ones we register that this will be the tile we've pressed on, and this will be the tile that we've released our mouse button or our finger on, so that we can swap them. So this is get mouse button down. If we've hit something, we grab hold of the object that we hit, which is the first tile that we put our finger on. Okay, then we go else. If the mouse button has come up, or if the finger has come up, and we've already found a tile, tile 1, then we're going to shoot another ray into the screen. And if that hits something, that's our second tile. So now we've got hold of our first tile our finger was on and the last tile our finger was on. Okay, so the next part is to test if we have 2 tiles, then we're going to swap their positions. So we create a temporary position to hold tile 1. And then we set tile 1 to be tile 2, and then we set tile 2 to be the temporary one. And once we've done that, which swaps them around, we then set tile 1 and tile 2 back to null, or to being empty, so that we can then swap another 2. Okay, so you might want to now pause the screen on this to type this code in. This is the input part for the first touch, and then there's an else for the second touch, I should say, when the finger comes up or the mouse comes up. And then if we save that and switch back to Unity and play it, we can now swap. So if we click on this guy, drag the mouse across and release it on this guy, it will swap them over. Now, the thing with our code is it doesn't care where you swap them. So I can swap this guy with this one down here. It doesn't do any tests to see if they're next to each other. But at least this bit's working. So the next thing is to determine that the ones we're swapping are horizontally next to each other or vertically next to each other, which is the way these Bejewelled type tile swapping games work. Actually, before we start testing whether they're next to each other, that you can swap them, we need to do one more thing with the code. When we swap them like this on the screen, we're swapping these game objects with each other. Now, if you remember, we've got these game objects also recorded in our 2x2 matrix. So that is our array in memory that's holding on and pointing to these little guys, which will help us later on when we want to check whether there's a match of 3 or whatever going on. Now, if we switch things around on here and we don't then switch them around where they are in that 2-dimensional matrix, then everything's going to get out of whack. So we need to go back into Create Game, and I've already inserted this code, but you now need to add this in. So this is inside of our finger up or our get mouse button up else statement in the update function. And inside this, if tile 1 and tile 2, before we actually swap the physical locations of the game objects, we need to update their position in that matrix. And we do the same thing that we did with the physical objects, where we put tile 1 into a temporary position, set tile 1 to tile 2, and then tile 2 to be the temp. We do the same thing in here. We put tile 1 out of that matrix into a temporary variable. Then we swap tile 1 with tile 2, and then we set tile 2 to be the temp. So add this bit of code in after this if statement. Now, when you run it, you won't see anything happening any different than before, because this is the code that is just keeping track of where things are in the grid in memory. Right, next we're going to just bring in a sound so that we can play an error sound when we try and swap tiles that can't be swapped. So I've got a file, buzzer.wave. I'll just drop this in here. And if we play it, okay, so you're going to hear that when you try and swap something that can't be swapped. So that's our error message. Now we want to actually attach that to the main camera, since it's the one doing all the work with our create game. So we will add a component to that. Just have to remember where it is. Oh, there, audio source. And we're going to drag our buzzer into the audio clip like that. Now we don't want it to play on a wake, so let's click that off and everything else should be fine. Okay, so now comes the part of the code that's going to test whether two objects are next to each other to allow us to swap it, so that we can only swap them. If we play this, we can only swap these two. We can't swap this one with, say, this one. We can swap these two again, but we can't swap this one with this one down here. So opening up our create game script, and I've already got it in here through the magic of YouTube videoing. Here's our if statement that we had before that we were editing, and if you just go down a little bit more, this is the code. Hold on, no, this is the code we just added. So this is the code that swapped the tiles in our two-dimensional matrix. So just before we do any swapping of the tiles in the matrix and the actual tiles themselves, we're going to add an if statement in to check that the horizontal distance and the vertical distance between the tiles is only 1. Because if it's not 1, then the tiles are further apart. They're not next to each other. And if they're not next to each other, they're not allowed to be swapped. So we work out the horizontal distance between our two tiles. We work out the vertical distance between our two tiles. And then we check whether one of those things is 1. And we use an XOR statement. This is this symbol. Now, this is a logic symbol like and or. You mightn't have seen it before. It's not used that common. So this XOR means that this has to be true or that has to be true, but they can't both be true. Because if they're both true, it means you're trying to swap tiles on a diagonal, which is not allowed in this version of the game. Okay, so we're using the XOR. As long as one of them is 1, then we are swapping with a neighbor. Okay, so the start of the if statement then begins above where we're swapping our tiles. It ends after we swapped our tiles. So this is the part that you need to add after you've set your tiles back to null. And this will play the audio source, the buzzer. So if we're not swapping a neighbor that's vertical or horizontal, then play our buzzer sound. All right, so if we save that and go back to our game and run it, we should be able to swap these guys, but we shouldn't be able to swap these guys. Or this one and that one. But we will be able to swap these. Alright, so that is all the particular mechanics in place for this game. The next thing is to check whether there are 3 in a row. And if there are 3 in a row, like this, then we want them to magically disappear. So that involves looping through our entire grid and checking for 3 in a row horizontally or 3 in a row vertically. We're now going to create a really large function to take care of checking for all of the matches on the grid. So it needs to go through the entire grid and check if there are 3 matches horizontally, and it needs to go through and check if there's 3 matches vertically as well. And if there is, then those tiles should be removed from the game board. Okay, so if we go back to our create grid script, we're going to add a function underneath update. So a new function called check grid. And now this is quite a long function. So I'll go through it. We're going to loop through the internal grid. So that's the 2D matrix we created at the beginning. So we're using the same nested for loop where we're looping through the rows and the columns that you can see here. And then we're checking that the tiles actually do exist in the positions before we compare them. So in this case, we're checking in the columns, and we're going to first of all check if the current column row tile is equal to the next column, the column next to it, so C-1 in this case. So we're starting in the column number 1. So if the tile in column number 1 is the same as the tile in column number 1 minus 1, so that's like the first column, because remember we start at 0. If those types are the same, remember type has the tile's name in it, you know, like angry clone or smiley clone that we put into it when we first create it. So if those 2 types are exactly equal, then we're going to count that as a match. And so basically we zoom through here until we find a counter. We get a counter of 3. When we've got a counter of 3, we've matched 3 tiles. And you can see here we then take the tile at column C, the one next to it. This would be to the left, and then the 1 2 spaces to the left, so those 3, and sets their activity to all false. So this is actually turning off the tile object itself. And then it goes through and sets the positions of the internal matrix for those tiles to be null as well. Then we're going to set this renew board Boolean value to true, and this will be used by another function a little later to add new tiles to the board after we've started removing them. Okay, now we do the same thing again, but now we check all of the rows. So we start going through them, and then we go through and match. If they match, we add up a counter. When that counter adds up to 3, we set all the tiles to not be active, and then we set them all to null on the in the internal matrix. Don't know what that extra semicolon is doing there. We don't need that. And then we set our boolean for renew board to true once again, so that the program knows that there's been a match, there's tiles that are now missing, and the board needs to be renewed. After all of that, we then have this if statement for renew board. So if the renew board is true, which means tiles have been removed, we're going to run this function renew grid and renew board. Now this is commented out at the moment because this renew grid function doesn't exist. So you can just leave that there. This bracket here is the end of our check grid function. So I'll just go back up to the top again, and as you type it in, you might want to pause the screen. So it goes from here and down to here. This bracket is the bracket for the class. So all of your other functions, start, update, etc., are inside there. Right, so once you've got that, save it, and then switch back and run. Now, in this instance, you can see that it's already found some matches. Oh, actually, one thing you wouldn't have added to your code, if we go back in, is that you need to run this check grid function. And we do that at the top of the update. So the first thing we do in update is run check grid. So you'll need to type that in there. The other thing you'll also need to do is to add, right at the top of your class definition, this boolean for renew board. And we will initially set it to false because we're not having to renew the board just yet. Okay, so now when we run this, when you run it, you will find that, well, in this case, there were no immediate matches, but if you swap these, then you'll see that they disappear. So anywhere you can make 3 in a row will cause them to disappear. And there's no renewing occurring just yet. That's why if you restart it and just by random chance you get 3 matches, it will remove them immediately. Now the last thing to get this working is to renew the board tiles. What we want them to do is to drop down vertically. So if you remove a line from the bottom, you want all of the tiles above it to shuffle down into that space, which is the way that Bejewelled works, the way that Candy Crush works, and the same way that Tetris works as well. So the code's going to loop through our grid and look for any empty spaces, and if it finds it, it's going to shuffle the ones above it down. If there's an empty space in the top row, it will actually create a new tile and stick it there for us. So they eventually rain down from the top. So once again, in our create game code, we're going to add a new function to deal with renewing the grid. So at the bottom of the check grid function that we created just before, we left these 2 lines commented out. We're now going to write renew grid, so we can put these back in so that if the board needs renewing, then it will run the renew grid function. Okay, so directly below that check grid function, we're going to add in a renew grid function. So renew grid starts by shuffling the list of our pooled tiles that we've got to the side. It's like shuffling the cards and then putting them back into the spots that are empty. First, it checks the top row. If there's anything in the top row, then a new tile needs to be pulled out of the tile bank and placed into the grid. If it's not in the top row, then it's a space that is now empty in the grid because the other ones have been taken away. So we're going to shuffle all of the tiles down the grid. So anything in, for example, row -1 will now come down and they will constantly fall down through that grid structure. And if tiles do move, we then set this any moved Boolean value to true, because if they do move, then they're going to leave blank spaces above them, which means the whole process needs to happen again. And when the whole process happens again, we need to shuffle the list and keep going. So at the very bottom, you can see this if any moved will invoke the renew grid function again, and so it will run itself again. It'll keep running itself until the tiles become at some equilibrium where they're not moving anymore, which will allow us to then interact with it. Okay, so this is the last bracket in check grid. Excuse me. Then we add in renewed grid function with this code in it. And this is the bottom of it. Okay. This bracket is the last bracket in renew grid. And this is the last bracket in our class. Very important to have all our brackets lined up. All right, so save that, come back into Unity. And then if we run it, all right, so what you saw there was that initially there were some matches and the grid renewed and filled itself up. And this could happen if we just restart it again a number of times based on how many spaces there are. Okay, so now we just need to look for some matches and move these around, and you'll see that the grid's renewing itself. I'm not very good at this, but here we go. Okay, and that's it. That's the end of the tutorial. That's the basic mechanics behind Bejewelled and the matched 3 mechanic. And if you want to get fancier, you can match 4, have bonus points for that, match 5 or match crisscross, which will just come down to doing more checking in this create game function. So the part that we're checking in is, if we just go up a bit, is check grid. Okay, so this is checking for 3 in a row because it's saying, you know, if our counter is counted up to 3, then we've obviously got 3 in a row. You could change this to 4 and it would do 4 in a row. You could change it to 2 in a row, that kind of thing, and that will just fix it for you. So all you need to do if you want to run this on a larger screen is to go back to the top and change these 2 values here for how many rows and how many columns, and adjust where the camera is. And this code, when you push it out to a mobile device, will work just fine because of that get mouse button down, this here, working as a finger touch as well. So thanks for listening. Hope you learnt something and have got the starter of a great tile game.